All right, here we go. Chapter 11 review. This is the extra review sheet I give you guys. So find the area of the triangle below the nearest thousandth. All right, so we have the first triangle. Now, the option here is if you get the formula, remember you can draw the height in, figure the height out using SOHCAHTOA, and then just do 1/2 20 times whatever you get for the height. The other formula we use is the area is equal to 1/2 AB times the sine of C. Remember, A and B are just any two sides, and C is the angle that's between them, right? That's in between them. It's called the included angle, okay? So here, A and B are going to be 14, okay, and 20, and C is going to equal that 65-degree angle. So we just, area equals 1/2 14 times 20, and then times the sine of 65. So this is going to be 140 times the sine of 65, and then we'll type that in our calculator, and we'll see what comes out to be. Remember, when you get your calculator, you can move your cursor up to the corner there where the battery is. See that, make sure that you're in degree mode. You can do home 5-2 and check the angle as well that way. So 140 sine 65, hit enter, and there we go. It's 126.883. Nearest thousandth is going to be the 3, so the next number is 0, so we're going to keep it. So this is 126.883. No units, so you can just do unit squared if you'd like, but you don't have to. Okay, in the figure below, we have an isosceles trapezoid. This is important. This is a big one, okay? This trapezoid has two congruent sides here. All right, it's contained inside a rectangle, also important, so we know that these are right angles, that these sides are congruent, top and bottom are equal as well. Find the probability of point is chosen from the figure below being the shaded region. Over here. So first thing we need to do is figure out what these two parts are, okay? We know that these are both 13 meters. In order to get the area here, I have to get this height. I have to get the side here. Now remember, this altitude of the trapezoid here, these altitudes, are going to show us that this piece right here, if this is 8 here to here, that there's 10 units left over for these two triangles on the side. And we know that these two triangles have to be equal because it's an isosceles trapezoid, okay? So if there's 8 from here to here and there's 10 left, that makes these two pieces 5, all right? And then all we're going to use is Pythagorean Theorem, right? Well, we can do c squared minus a squared is equal to b squared, and just plug in. So 13 squared minus 5 squared is equal to b squared. This is 144, and the old square root here is going to show us that these altitudes, these heights, the sides of the rectangle are both 12. So now we can actually do this, right? I can calculate the shaded region by just doing the area of the triangles and doubling them, or doing the rectangle minus the trapezoid, so it's up to you. We'll just do the area of the triangle. So the area of the triangle is 1/2 base times height. You can use 1/2 AB sine C as well, right? AB and the sine of 90. It's up to you. The sine of 90 is 1, so you'll get the same formula actually. So 1/2 12 times 5, and this area is going to end up being 30. So that's one of the triangles. Remember, there's two triangles, so the area altogether is going to equal 60. All right. The area of the rectangle, if you remember, is just base times height. The base is this side, which is 18. The height is 12. And so we end up getting a lovely, I think it's 156 here. Oop, I was wrong. 216. And that's the area of my square there, okay? Rectangle, I should say. Now, if you wanted to do the area of the trapezoid, you could, okay? And we'll just review that since we're here. It's 1/2 the height times the sum of base 1 plus base 2. Or, right, you got these two triangles and a rectangle, so feel free to do the areas and add them together, okay? So 1/2 the height is 12, right? And the sum of base 1 plus base 2 is 18 plus 8. So this is 1/2 times 12. That's really just 6, right? And then times 26. So that's 36, carry 3, 12, 1. And there, hey, there's my 156. So the difference between these two things would give us the shaded area. And I bet you it's 60. So that's what we're looking for. So the probability, remember the probability of the shaded here, right, is going to end up being the area of the two triangles divided by the area of the rectangle, or the area of the rectangle minus the trapezoid over the area of the rectangle here, okay, which is going to be equal to 60 over 216. And if we want to, we can reduce it. We can make it a fraction. Okay, but it's 0.27 repeating, which is also 5 over 18. Any one of those things is appropriate here. So either one of those is good. All right, find the area of the shaded sector, and it's defined or bounded by this angle AOB, okay? And we also want to find, and there we go, and the length of the arc. So we're doing both, okay? So let's do the area of the shaded region. That's the area of the sector. Remember, that's the angle called theta over 360 times, and this is area, so it's pi r squared. If this is 240 going around here, that's 120. It's just 360 minus 240. That's the measure of the arc and the angle in degrees. Okay, so it's 120 over 360 times pi times 6 squared. Oop, lied. 7 squared. So this is going to be 1/3 of 49 pi, which is just 49 pi over 3. We are going to type this in the calculator and round it out. So 49 pi over 3 ends up being 51.3 to the 31 to the nearest hundredth. And this should be feet squared, by the way. So that's the area of the sector. Okay, the arc length, if you remember, is the angle over 360 once again times 2 pi r. All right. So the angle is 120 over 360, and then 2 pi times the radius, which is 7. So this is 1/3 times 14 pi, which is really just 14 pi to 3, but either one is okay. Type in the calculator, hit enter. It's going to be 14.6. And this is in feet. And that's our arc length. All right, so there's the two answers. Number 4, find the length of arc LMK. So LMK, remember, travels from L through M all the way to K. This is 30 degrees. This is 180. So this arc and the angle, formed from there to there, is this 180 plus 30, which is 210 degrees. All right. Now the radius we already know is 18. It's shown. So the length of the arc in terms of pi, once again, so it's theta angle over 360 times 2 pi r. So we're going to go with 210 over 360 times 2 pi times 18. So we can reduce 210 over 360. You can also just type that whole thing in your calculator. Okay, that's up to you. This is going to be 7 over 12, and this is times 36 pi. This is going to reduce, and it's going to become 21 pi. And then this is inches, and that's the length of the arc. Convert the following into radian measure. Okay, so if you want to do it by hand, we're doing radians or degrees, d over r, and then you're doing 180 where the degrees is, same level, over pi for the same level in the radians. Plug in. So 150 over r is equal to 180 over pi. I cross multiply, so it's 180 r is equal to 150 pi, and then I divide out by 180, and then I just reduce. So I'm not going to type the pi in when I reduce. It's just 150 divided by 180, and I'll convert to a fraction, and I get 5 over 6. So I got to remember that there's a pi attached. So this is 5 pi over 6. That's it. And then we do the next one. So it's degrees, negative 420 degrees, over radians is equal to, and it's 180 over pi. We cross multiply. 180r is equal to negative 420 pi. We divide out by 180, and we get our radians. So negative 420 divided by 180, right, is negative 2.3 repeating, which ends up being negative 7 over 3. So this is negative 7 pi over 3, or negative 7 over 3 times pi. Either one is it's the same thing, so either one of those is acceptable. My feet are falling asleep here on a small desk. Good times. All right, next one, 288. It's the same thing. 288 over r is equal to 180 over pi. Cross multiply. 180 r is equal to 288 pi. Divide by 180. And then r is equal to, what do we get when we reduce? So 288 divided by 180 gives us, yours is going to come out to your fraction right away. It's 8 over 5. So it's just 8 pi over 5. And there's our radians. Convert from radians into degrees. The super shortcut method. Pi radians, right? Pi radians is equal to 180 degrees. So when we convert from radians to degrees, we just plug 180 in for pi. It's 4 times 180 divided by 5. What do you get when you do that? 4 times 180 divided by 5. Hit enter. It's 144. This is equal to 144 degrees. That is it. 7 times 180 divided by 4. That's all you have to do, people. 7 times 180 divided by 4. There you go. Oh, don't do that. Don't do 480, people. 180. All right, there we go. And that's 315. You do negative 8 times 180 divided by 9. And there's the next one. So this is negative 8 times 180 divided by 9. And this is equal to negative 160. I'll redo these on the calculator later so you can see the conversion from radians to degrees. But that's it. All right. Okay. We'll just keep doing. We'll do one video here. Number 7, use the diagram or write to answer question 5. So area of circle P in terms of pi. So circle, wow, this should be O. Awesome. Circle O in terms of pi. So this is just pi times r squared. R is 6. So pi times 6 squared is equal to 36 pi. That's it. Area of sector AOC. So AOC is the whole slice of pizza here, right? This whole thing is 12 pi. Find the measure of angle AOC. All right, so the area of the sector formula we know is theta over 360 times pi r squared, and this is equal to the area of the sector. So we're plugging 12 pi in here. The angle we don't know, we'll keep it as theta over 360 times pi r squared. We already know the area, it's 36 pi. So you can just plug that in. This goes to the top, remember, right? Okay, so we get 12 pi is equal to 36 pi theta over 360. I'm going to show you a shorter way to do this in a minute. You're going to say, why did you ever show us this? But this is following our technique we've been using, so we're going to stick with it. I cross multiply. So 12 times 36. 12 times 36, 360. Is 4,320 pi is equal to 36 pi times theta. You could also have reduced this, right, and got pi theta over 10 and also done it that way. It's okay. We're going to divide by 36 pi, and we're going to get our answer. So remember, the pi's cancel. That's important to remember that. Otherwise, you're going to get a different answer. You're going to get some crazy decimal, and theta is equal to, in this case, 120. Now, here's the shortcut, right? We already know that the whole circle has an area of 36 pi. What's the part of the circle of the area, right? Is 12 pi. So if we just do whole over the part times the degree measure, 360, this will also spit out our angle measure. This is the part of the circle times the angle measure. So notice, whole is, flip it around, people. Part over whole. So the part is 12 pi over the whole, which is 36 pi, times 360. So watch what happens. Ready? Okay. So this is telling us how much of the circle we're using. So 12 pi over 36 pi. And we want to do this, remember, in parentheses here, right? And then times 360. Boom. There's the 120. Okay? So this is just a shortcut method, if you want to remember that. Okay, find the area of angle AP, triangle APB to the nearest tenth. Remember, we're going to use, and this should be AOB, not PB. Okay, AO, all right, and this should be AOC. What is going on with this problem? We changed it a little bit, and we forgot to switch the letters. So AOC, so it's this triangle right here. So remember, the area formula for a triangle is 1/2 AB times the sine of C here. We don't have a height, so we're going to use this formula. So it's 1/2 6 times 6 times the sine of, and remember from our last question, we got 120 degrees for the angle, so the sine of 120. Nearest tenth, people. So half of 6 times 6 is 18, but we can just plug it in. 1/2 6 times 6 times the sine of 120, and booyah. Nearest tenth is 15.6. And then this is inches squared. Okay, this is also inches squared up here. All right, find the area of the segment bounded by right segment AOC is nearest tenth. Find the area of the segment here bounded by that angle, right, and the chord. So here we go. We are going to take the area of the sector we got from part A. Nope. We got from part C. Okay, and we're going to subtract away the area of the triangle. So we know the area of the sector from part B right here is 12 pi. We're going to take the area of the triangle away from that. So it's the area of the sector minus the area of the triangle. That's the area of the segment. Okay? So this is equal to 12 pi from part B minus 15.6 from part C. And all we're going to do is type it in and subtract it. 12 pi minus 15.6. And there we go. It says nearest tenth, and that's 22.1. And that's the area of the segment. Okay, number 8, in the accompanying diagram, a figure of triangle ABC. AB is extended through point D. Find the area of triangle ABC. We know AC is 12. This is important. The angles are equal, so this angle is equal to this one, which means that these two sides are equal, and this side is also 12 inches. And we know the triangle, the area of the exterior angle here is 123. Now, what we need to do in order to figure out the area of this triangle is get the measure of the angle that's in between them. We have to have this. So this is B, that's A. So for my formula of the area of the triangle, 1/2 AB times the sine of C. Okay, we know A and B are 12, so it's 1/2 12 times 12 times the sine of, I don't know, we got to go get it. Now, we do know that these two angles have to add to 180. So if we just do 180 minus 123, that'll leave us with 57 degrees. And that's the measure of these two angles down here, those two base angles. So if we take 180 and take away the 57, we'll be good to go. Or the exterior angle theorem says that this guy minus the 57 should equal that one too. So either way, you should be okay. So we'll just do 57 plus 57, and this is equal to 114. And then we just take away 114 from 180, and we get 66. And that's the measure of that angle, 66 degrees. So we plug in 66 for C. We grab our handy-dandy calculator. 0.5 times 12 times 12 times the sine of 66. And I end up with, and it doesn't say what to round to, so we'll just write out the whole thing because we're crazy like that. And it's inches, so it's inches squared. And that's the area of our triangle. All right, once again, you could drop a height, figure out the height, and you have to figure out the pieces down here. It gets a little crazy, so we're just going to stick with that one. All right, number 9, a circle has a radius of 4 inches. Circle, radius, 4 inches. What is the length of the arc intercepted by a central angle of 2 radians? So that means, essentially, right, that there's 2 radii going around the circle. 1, 2. Going 2 radii around the circle. How long is it? So it should make sense if I'm going 2 radii, the answer should be 8, right? And if we use our formula, right, the arc length is equal to the angle, we'll call theta, over 2 pi times 2 pi r. The 2 pi's are canceled, so it's just theta times r. The angle is 2, that is 4, and the answer is just 8, right? That's it. And this is inches. That's our arc length. You're done. Okay? Same thing here in a circle. The length and arc length, so the length already from here to here, let's say, right, is 2/3 of radians. So from there to there, this is 6.6. The central angle is 2/3 of a radian, so it's 2/3 of the radius, okay? And we want to know what is the radius. So we know the formula, theta over 2 pi times 2 pi r. These are going to cancel, so 6.6 is equal to 2/3 times r. If you want to divide by 2/3, you're more than welcome to, or you can multiply by 3/2, because that's the reciprocal. So 6.6 divided by fractions, 2/3 with parentheses, and I get 9.9. So that's my radius. All right. This problem might look familiar. We did this earlier. It's on the other sheet. That's okay. We'll redo it. Circle with a diameter of 24 centimeters and a central angle of 4 pi over 3 radians intercepts an arc. So circle, radius is 12. The central angle is 4 pi over 3. All right. Radians. So once again, you can convert this to degrees if you want, or we can just use our formula. Okay. So here we're looking for the length of the arc. Arc length is equal to theta over 2 pi times 2 pi r. The 2 pi's cancel. So it's just theta, which is 4 pi over 3 times our radius, which is 12. And we already know this should come out to be 16 pi centimeters. Doesn't say with a round 2, so we're good to go. Circle B has a radius of 14. Angle B intercepts the arc with a length of 6 pi. Find the measure of angle B in radians. Okay, so once again, the arc length is equal to theta over 2 pi times 2 pi r. The 2 pi's cancel. So I get 6 pi for my arc length is equal to theta times 14. Divide both sides by 14. And whatever you get for this is your answer. Now you can reduce 6 over 14. And that's equal to 3 over 7. So this is just 3 pi over 7 radians. And that's theta. And that's it. All right, guys, good luck. Let me know if you need anything else tomorrow. Partner quiz. See you then.